Yeah, so there's this question. I hope the transmission broke just before that. Whether we shall migrate to the latest Java version, being Java X at the time, or stick to the latest LTS. Uh, for now, it's not that. I mean, for at least until March, it's not that much important question because the latest Java version, meaning Java 17, is still LTS. Yeah, there are some people wondering whether if they should go to something new or not, right? And the answer is, of course, it depends because if your software runs using the latest Java version, like for example it was Java 15 or 16, then of course I think you should upgrade it because why not? Because you instantly start benefiting from the all the goodies like new garbage collectors, faster startup times, and so on and so on, right? Of course, maybe we shouldn't be using preview features in production, but beside that we should be good to go. And I'd like to highlight you the true meaning of LTS. And now this is a wall of text, but please don't worry about this wall of text, okay? What's really important here is the last message, the last sentence here from this message of Mr. Mark Reinhold himself. Whether the target release is an LTS or not is, in almost always, completely irrelevant. So as you can see, it doesn't really matter when you develop Java or when you use Java. LTS is actually a business term. Think of it this way. So it's basically a promise made by a company or a vendor that they will support a given Java version of that period of time or another period of time. And by the way, this policy has changed recently. So now we are not going to see LTS every 6-year releases or 3 years. We're going to see LTS every 4 releases or 2 years, right? So the next LTS we're going to see is Java 21. So let me state this again, that neither non-LTS releases nor preview features are, as some call it, monkey soft or banana soft or something, I don't know, rubbish or not reliable or something like this, something that should be avoided and skipped. That's not the case, right? LTS means business, doesn't mean security, robustness, technical stuff, and so on and so on. All right, so coolest features in recent Java versions, according to me. Of course, your choices might be totally different. So my choices are new garbage collectors, ZGC and Shenandoah, of course, records, then pattern matching for instance of, pattern matching for switch, which we see as a first preview feature in Java 17. Then this movement towards strong encapsulation, meaning that illegal access is not only denied but actually it's removed now. Sealed classes in Java 17 and other good stuff from projects Valhalla and Panama in these last 3 versions, right? So if you don't know, Valhalla is about basically in very maybe like too naive way, but it's about using less memory, right? And Panama is about the native stuff, so we can use native libraries, allocate off-heap memory, and so on and so on. And there are also helpful null pointer exceptions. So let me talk briefly about Shenandoah GC and ZGC, which can both support heaps up to 16 terabytes. I mean, there was a buzz, right, that the new mark is going to be 64 gigabytes of memory, and now think this is like terabytes. So imagine how huge heaps you can have if you really need to. And they're about short stop the word pauses. So we are not going to see, or shouldn't we see, something longer than 1 millisecond. And that's not a mistake. I mean 1 millisecond, right? This is the aim, or maybe this threshold is going even lower and lower. They achieve that because they're compacting the memory concurrently, and they are single generation garbage collectors, although this is something that's going to change. So we're going to see like young and old again. And they operate using jitting barriers, right? So this is how they work, because when you compact concurrently, you need to know whether the object reference is still valid or not. And there's one caveat, or one thing you need to remember, that these short pauses don't come for free, because short pauses are achieved by working concurrently, meaning there's going to be more CPU used, right? So if you're about like batch processing, perhaps you'd like to stay with the other garbage collectors, but if you are about online processing and you really want to have these garbage collection pauses as shortest as possible, and you can sacrifice more CPU power or pay for more CPU power, then you should choose one of these 2 garbage collectors. How to choose them? It's really simple. So for Shenandoah, you just go XX and use Shenandoah GC, and you specify the maximum heap size, as I mean, that's a good practice anyway, right? And the way it works, it's using so-called forwarding pointers, and these are very nicely described in Alexis Shepiliov's blogs or talks. I really recommend you to take a look at these. And how to use ZGC. You just go for XXU ZGC and again specify maximum heap size, and they work not on forwarding pointers but on colored pointers. And again, there's a very nice talk from Erik Österlund, or there's a ZGC webpage you can visit, right? And there's more about these GCs. I mean, I could talk about them for minutes, but I encourage, if you're interested about these, how to actually run them, please play this video for at least a few minutes. And there's another very nice change that we saw in Java 16 and Java 17, meaning that it's about strong encapsulation of JDK internals, right? Now it's a standard feature introduced in Java 16 as this JEP. I mean, all the links are clickable. You're free to follow them, and the slides are online as well. I mean, you should be seeing the link down there, and it will be also at the end. So as we know, modules were introduced to Java 9, and they brought us these warnings about illegal access, right? So when you do stuff, you see these warnings, illegal access occurred, and perhaps you pay attention. Unfortunately, some people don't pay attention, and I'm going to show you why this might be somewhat problematic. Some suggest that these are just warnings, so ignore them, right? And the worst part of this was that some people actually follow these advices, right? So when we take a look at this switch, illegal access permit, it was meant to be temporary, right? Let me show you that. Yeah, so we should have this piece of code, because in code we trust. Also, the code is online for you, so you can clone it or download it and play with it as you wish. Yeah, so this is it. So let me run this code. Right, and as you can see, I have Java 11 here. So when we go for Java and I run it, we see this illegal reflective access operation has occurred, and so on and so on. And people said, yeah, this is just a warning, so ignore it, don't worry about this. What matters is that we see this thing, right? And some people paid attention about this thing, and there are two things you can do. So first thing is, actually, that there are more things. Let's get back to that. And now the thing is that illegal access is default in Java 16, was switched to be default in Java 16, right? So as you can see, in Java 16 the application didn't even work, right? And some people said we should go for illegal access equals permit, right? And now, as you can see, the application keeps running and nothing actually changed. Well, one thing changed, and the thing is that not only that it's no longer permit but set to deny, but it says here, as you can see, option illegal access is deprecated and will be removed in the future. And now, we, as some say, live in interesting times, which might be good or bad. And I can tell you for sure, I can use this marketing cliche that we live in the future, because the future is now, my friends. Because when you try to run something like this using Java 17, which was released over a month ago, as you can see, it doesn't work. It's because the support for this flag has been removed in Java 17. So this advice just said illegal access permit, or don't worry about this, turned out to be a false friend. So what we have to do actually is, now we have to analyze all these stack traces. So using previous Java versions, you can go for example, illegal access debug. It will show you such a beautiful stack trace. And based on this, you can tune this add opens options, right? So now when I paste it, I can see no warnings, basically, and the application works. So this is something what you can do when you really desperately want to run this program and can't touch the sources. Because what's actually the problem here? Let's think about the actual problem for a moment. The actual problem here is that we are summoning the demons of deep reflection by calling this set accessible true, right? So some say you summon demons by, I don't know, drawing pentagrams, lighting black candles, and so on. In Java, you do that by using set accessible true. And this, in my opinion, is also a bad thing. So ideally, instead of using this add opens, what you can do, I mean, sometimes it's unavoidable, but what you can do is just basically rewrite the code or fix the code so it's not using this set accessible true. So what can we do here? We could actually go for input, all right, input, and get bytes if I'm not mistaken. Yeah, let's do that for UTF-8, right? And now just to examine the value here, we'll use this. As you can see, I'm removing this piece of code because it's not needed. Then I don't need this, and I don't need this, and the code got so much simplified. And let's do let's do the same thing here for this instance. So let's go for now and get epoch seconds. Okay, and let's use it just here, all right? And as you can see, I'm removing the other set accessible true, right? And now I should be able to run this code without these add open switches, right? And let's see if that's the case. Yeah, as you can see, so this issue can be addressed in two ways. I mean, when you see such warnings in Java, when you try to run your code or dependencies you have in Java using Java 17. So what you can do is, this is like, I would recommend this. Just stop calling these demons, right, from the abyss. Stop using set accessible true. That's the ideal situation. I mean, the object-oriented programming and encapsulation were invented for a reason, right? And maybe it's nice to follow this principle. And if you can't do that, then you switch to illegal access debug or warn in previous Java versions, and then you start populating these add options, right, switches. And if you can't do that, or if you don't want to do that, then you just set the illegal access permit or don't upgrade to Java 16, and you just keep producing legacy code for future generations, right? This is what you can also do. Just stay with, for example, Java 11 till the end of your days, because why not, right? And I even wrote a poem about this. Roses are red, reflection my hate, you shall not use illegal access permit. So there's a blog post what to do regarding this. Basically that my program crashes, and it crashes because it says inaccessible object exception, or it yells about this illegal access permit being no longer available, right? So basically you have to do what I just have shown you. Yeah, and how to do that, if you need like more steps, how to identify it, I gave a talk at Devox Poland like a few years ago. And yeah, this is the thing I'd like us to remember, that in Java 17 they added this JEP 403, and I'm not sure if this is an Eastern egg or not. If it's not, then it's like a perfect coincidence, but really I can't tell. But for me, it's like, we know the HTTP code 403, right? So it means access denied, and so is this JEP, means access denied to internals unless you use these add opens, meaning that you say that this is not the daemon, this is something that I really need to have in my code because reasons, right? But then you do that in a conscious way. So in Java 17, basically illegal access is no more. Records, right? So records are a standard feature introduced in Java 16 as this JEP. We saw two releases of incubation before, and these are a new kind of type declaration, and record is a restricted form of a class, pretty much like enum. I mean, this is of course not exactly the same, but as we know, enums are classes with objects, and they have some restrictions on them, and so is the record when you start thinking about this. And it always extends Java lang record, and I still have this typo, it's so embarrassing. These are meant as transparent carriers for immutable data. So you need to remember that your data, when you want to pass your data between various pieces of your program, right, then you can use records if you use them for immutable data. And these are meant as transparent carriers, meaning for every piece of data, you will have an accessor, which is basically like a getter only without this get or is prefix or something like this, and then you can access everything that's inside, and the data doesn't mutate. I mean, once you create the record, it doesn't have moving parts unless this data is mutable inside, which I would say isn't a good sign to use it in a record. And this is how you use or declare the record, right? So instead of using class, you just go for a record, and then you have the name, and it always need to have the body. And what's new is this so-called header, right? So we go and list all of these record components. So for example, for complex numbers, we could have real part and imaginary part. So this is how it might work, right? And unfortunately, I could talk about records for like an hour or longer. Sometimes I even do that with Rustam, who's having another session right now. So please watch another talk, which is Java Records for the Intrigued, if you really want to know more about using records, how they operate with modern libraries, and so on and so on. Because basically I could use this whole talk just talking about records, and I don't want to do that because there's a lot of other interesting stuff waiting for us. So for example, pattern matching, for instance, of thing we see since Java 16, right? So we know this code all too well, right? So we've seen it so many times that you have an object and you suspect this might be an integer, and you want the compiler to double it for you. So we ask the compiler, hey, if this is an integer, please let me in. And the compiler says, yeah, sure, this is an integer, please get inside. And you can't just go in double object, because the compiler would say, whoa, why are you trying to double an object? But this is an integer, you just allowed me to get in, but I don't know it's an integer any longer since I'm in this block, right? And that's why we had this ceremony. I mean, basically, as you can see, we had to use integer here, and integer here, right? And it's no longer the case since Java 16, because we can alias it now, right? So as you can see, I'm just asking my compiler, hey, Mr. Compiler, if this object is an instance of integer, then please alias it for me. And once I have this aliased, I don't need any casting, any ceremony, any extra verbosity, or whatever we call it. I can just simply double this integer and it works, right? And this is called also smart casting by some people, I believe even Dr. Venkat Subramaniam himself. And as you can see, it's not only about ifs, because we can use the the benefits of circuit breaking, as you can see. So if this is a string, then I can check if this string is empty or not empty, right? And don't lie to me, we all have this method in our code bases hidden somewhere, right? Yeah, so these local variables from pattern matching, for instance of, aren't implicitly final, meaning you can then assign a new value for them if you really need to. They're visible only in the scope they declared, meaning they're not leaking, let's say, outside the if. They shadow the field names if you have such a clash, which I would say is, again, maybe not the best code to write. And we can go for more sophisticated setups, right? Let me show you this here. Yeah, so we can have, as you can see, something like this, and this code should be running. Let's see if it runs. Come on. Yeah, as you can see, it keeps saying, identifying that when I pass an object, that this object, for example, is string that has at least 3 characters, that's a positive integer, and that's a long that has at least 2 digits, and so on and so on. So as you can see, we can have such pattern matching with instance of since Java 16, and it should be working. Sorry. Yeah. So there are plans to evolve towards like a regular pattern matching, and these plans are happening on our in front of our eyes with Java 17. These could be very useful with records and reconstruction deconstructors. I mean, this pattern matching. So the thing opposite to constructors. So when we don't have a normally with constructor we have like a bunch of data, like few pieces of data, and we construct a new object, and with the constructors we do exactly the opposite. So using that previous example of a complex number, I would get the real and imaginary part in my hand, right? So I don't know if you're familiar with this concept of a preview feature. If you're not, it's about actually using -- enable preview when compiling your code and when running then your code using either class files or jars. And please remember the versions need to match, meaning you're not able to run preview features compiled using compiler from the previous JDK version. The versions of the JDK for compiler and for the JVM need to match. If you need to know more about this, again, I'm sending you to a video where I discussed this already, because I'd like to talk to you about pattern matching for switch, which is a preview feature in Java 17, right? And please remember that this old good switch we had, for example, since Java 7, with switch instruction or switch expression since Java 14 remains absolutely the same. Nothing changed there. If you see like a change in behavior, then please notify the OpenJDK team, because it means they have a bug, right? Okay, so let me show you actually how it works in code. We should have that in code. Yeah, how it works and how it feels. You see? So what I'm doing here, I'm just getting the my version of my runtime, right, the feature, and then I'm trying to generate a greeting. And as you can see, I'm passing an object here, so it's not an enum, it's not a string, it's not a number, right? I'm just passing an object here, and now I'm switching over this object, right? And there are a few new things you might see, but this code is running, I hope. Let's see. I mean, today is not a good day for running demos without power and with breaking internet, but yeah, apparently this worked. This is Java 17, right? So how did it work? We'll get to that in a minute. Okay. Oops. Or maybe that was the time. So what's new with this pattern matching is now we can also handle nulls. So I mean the switch is no longer hostile when it comes to nulls. Or it doesn't blow up with null pointer exception. When you're expecting something to be null, we can be expressive and say, yeah, this is null, and then I'm just doing something, right? And I'm not expecting it here. I mean, we could say null, and let's see how it works. So as you can see, instead of a null pointer exception, I see this illegal argument exception, because this is exactly what I wanted to have, right? And then we can have this pattern matching. So see, I'm matching with, this is an integer, right? As we had with pattern matching for instance of, and I can also use so-called guards, meaning I'd like to cover or have extra branch or extra case with not only this is an integer, but this is an integer that's at least 17, right? So that's why I'm saying that this is Java 17, and I don't expect this, because previous Java versions are not using pattern matching with switch. Unless you would change the code. I don't know, maybe Jable does something like this. And of course, we shouldn't get into this default at all. Okay, sealed classes. Sealed classes were a preview feature in Java 17, and they're introduced in Java in Java 15, and they're introduced in Java 17 as a regular standard feature. And when they become useful, sometimes we don't want someone else to extend our classes or implement interfaces, right? The ones we have, and we don't or can't use final, because then it means we can't extend these classes as well, or we can't have like a proxy classes or something like this, right? And we also sometimes don't want to reduce the visibility from public, because, for example, we might want to test it from another package or something like this. So and we want to prevent this bad slash unintended code reuse by inheritance, because I'd like to remind you that some languages, of course, don't have inheritance, right? For example, Go, and it's completely fine in their paradigm, but in Java we do have inheritance, and it's not that inheritance is bad, it's just it's used in bad ways, because when you try to model like various type systems or so on, it's fine, it's okay, and it's good to be used. But when you for example use it to for code reuse basically, then it might be just used in a bad way, right? So we are in a situation where we want to prevent this inheritance, right? And we can't use final, or we can't use public. So what can we do? Now in Java 17 we can use sealed classes, and when I say classes I also mean interfaces, but just for sake of brevity everyone says sealed classes, not sealed classes and interfaces, right? But it applies to both. So how does it work? We have a sealed as a new here indication here, sealed class, and now we can list the children, and each children then plays or it's like, because when you start sealing, every child gets or has to decide whether it's still taking part in this sealing or not. So the child number one or child one can say also it's also sealed, and it permits its own children or descendants or whatever, or it can be final. Then we of course don't use permits. In fact, we even can't, or we can opt out. We can say it's not going to be sealed at all, right? And why I use these square brackets here, because if all these classes are in the same source file, then this list can be implicit. I mean, then you don't have to list these classes when they are in different source files, because for example every class is a public class, then they have to be listed explicitly, right? And when you use modules, they have to be in the same module. When we are not using modules, then they have to be in the same package, right? We can't spread them between packages if we are just using class path. So this simple situation, okay, you are the library maintainer and you want to have your library type and inherit it here, in here, and then have two more children here, right? And these are these green arrows. And we want to permit this, right? And we want our users to be able to use our types, for example, this and this. So these types are visible for them, and these are these blue arrows. All right, and that's okay. What we want to forbid is we want to forbid this extension or inheritance here using these red arrows. Okay, so this is how we do that in Java now. Right, so I should have actually, let me switch. Yeah, sealing here, library type. Yeah, something like this, as you can see. So I have this sealed interface, and it permits two classes, right? And then this abstract implementation implements this type and permits two more children on its own, and these children are final, that's why they don't have this permits, and so on. And this is how you basically use it, just as I told you. When this parent, or let's say grandparent or great grandparent, is sealed, then everybody else in this family has to be either sealed or final or non-sealed. And this is working, this is nice. What we can't do something like this, right? As you can see, because this user lib type implementation isn't listed in any permits, it cannot extend this abstract type here, because it's not permitted here, or it cannot implement this sealed interface here. What works, however, is, as you can see, I can see these types, right? So I can use them as my field types or method parameter types, and so on and so on. This is perfectly fine. This is working, and this is how we should be using these classes or interfaces, right? So I'd say there are three ETs now in Java. They're kind of overlapping, but they're not the same. ET number one, which is visibility, right? We know this is public, protected, package default, or private. And these are the ETs we know from like the beginning. And in a way they were used for inheritance, because, for example, you cannot extend a private class, right? So reducing visibility, or you cannot extend a class that's in a different package if you're not in the same package, right? So this is how it worked. So we use this visibility for manipulating inheritance as well. Then there is accessibility, right? So this got introduced in Java 9 with modules. So even if a type is public but it's not exported, then we cannot not only see it but also extend it, because in general you cannot extend something that you can not see, right? This is why this didn't work, for example. So even now, even if a type is public and it's not marked as final, using modules when it's not accessible to third parties, it's not going to be not only used but also inherited, right, or extended. But now we have this third ET, extensibility, meaning even if a type is public and it's exported, so it's still visible and accessible for us, it might not be extensible because not only final but sealed classes, meaning sealed classes can be really like cherry picking and saying who's allowed to inherit or extend a class or interface or not. And it has like a great benefit for various let's say library maintainers, and I'm not only talking about like free open source maintainers, but also, for example, in your companies, right? We have like this core domains and core libraries sometimes to handle them, and we want to really model them well, and we don't want anybody else to extend it. So for example, then our switches or these chains of if else's break somehow, right? So this is when this sealing becomes really useful. Another thing, another very nice feature is helpful null pointer exceptions, which are standard feature now, and these are enabled in Java 15. So we have this code, we have this piece of code. I mean, it's not the best piece of code you've seen in your life, right? But it demonstrates something. So let's focus on this demonstration. So as you can see, I created this matryoshka style object, and then I'm printing this out, and now I'm passing this object of A to another class or method or something, and it's supposed to do something, right? And of course these parts aren't final, and so on and so on. So it might happen that someone will set, for example, a null somewhere here, right? And using Java, for example, 11, when you try to call this, you will get a null pointer exception basically. And now how to tell where the null is, right? It's virtually impossible. So there were two ways to tackle this situation. Way number one was wrapping everything in ifs. So if A is equal null, then warning. If a dot b is equal null, then warning, and so on, right? So just to handle it, not to encounter null pointer exception. The other way, just for people who wanted to know in which line there was a problem, people just use this, they hit enter, two slashes before that, and then again 2 slashes enter to make sure that every variable is in a separate line, right? But thankfully, this is not needed since Java 15, because Java will tell you where exactly the null is, right? It will tell you that it cannot read field F, meaning this field and whatever is there, because the E is null. This thing became null, right? So it's clear that this caller messed something with our objects and nullified this E. Hence, this F and so on will not work. If you think it's dangerous for your logs, you can disable it. You can opt out from that. But I think it's very, very useful for us in general for Java developers. So let's talk about some deprecated stuff. So what got deprecated? In Java 14, this combination of GC got deprecated, and Applet API got deprecated for removal, and Security Manager got deprecated for removal. And I don't know how many of you are still using applets. I believe like these days really nobody is using applets because they are not supported in browsers and so on and so on. That's why I think it's quite obvious this API should be removed, right? So it will be removed in future Java versions. This thing, however, Security Manager, is problematic for some people. I mean, since applets get removed, or will be removed, a lot of the purpose of the reasons for security manager to exist will basically vanish, will go away. That's why some say, or the OpenJDK maintainers / Oracle say, that's why it should be removed, right? But some people say they still use security manager, and it's in scenarios, for example, when they're running third-party code and they don't know upfront what this code will be, because, for example, people upload their jars and they execute their jars, things like plugins and stuff like this, right? So there's an ongoing debate what's going to happen and what substitutions we're going to have. Basically, we'll see some warnings and so on, and every call to security manager, once it's removed, will be basically passing, right? It's just, please be aware that security manager is now marked to be removed. That might be important for some of us, and some stuff got removed along the way, and actually I think it's kind of a good thing, because it means less moving parts, less things to maintain, so people, the maintainers, the architects, can focus on moving Java and thus the whole ecosystem forward. So as you can see, concurrent mark sweep got removed in Java 14. Nashorn JavaScript engine got removed as well, and we don't have any more Solaris and Spark ports, and experimental AOT and JIT compiler got also removed, and Nerimi activation got also removed. Among the things that I didn't tell you that were introduced, and these might be cool for some of us, it's, for example, now we have in Java 17 we have builds of a RH64, not only for Windows but for Mac. So if you're on Mac using M1, then perhaps you'd like to jump for Java 17, because it has an, like, now there's an official build of Java for your architecture, for your CPU. The code is available for you on GitHub for Java 15, 16, and 17. So everything I was showing you here isn't like hidden from you. You're free to go to clone it, to download it, and play with this. These are meant to be just like simple, usually one file, sometimes just a few files, but then one package demos, which you can go and play and run and see what happens with the given Java version. We had also like this various stuff. As you can see, applet gets removed or got deprecated for removal, right? And so is security manager and so on. There is this very nice formatting when it comes to hex format, right? So now we can do that without any external libraries, and so on and so on. Please let us know, I mean, the organizers and me, how do you find this talk? I mean, it hasn't been the best talk of mine because of the whereabouts in the weather, but I was trying to do my best, and sorry for the hiccup once again. So let us know what you think of this. Thank you very much for sailing modern Java with me. Please stay for the next session. I know it will be also about moving to new Java versions, and please remember that it's like, it's not only about like a matter of fashion or something, but it's about getting more efficiency, more productivity, and so on and so on. The slides are available for you here, and I think we've just reached the time back to the studio.